Hi guys, welcome to Code Bashers. So guys, as you all know that TCS NQT exams are starting from next week. So in this particular video, I will be discussing the previously asked actual coding questions which have been asked in TCS NQT. Guys, the best way to prepare for any exam is by solving the previously asked questions. So total two coding questions I will be discussing in this video. Make sure to watch this video till the end. And if you want to know more that how you can practice previously asked questions of different sections of TCS, that also I will be telling you in this particular video. So don't skip any part of this video. Make sure to watch this video till the end. And guys, we are continuously making videos for different companies preparation. Okay, we have made Accenture, Cognizant, Infosys, and now we are making videos for TCS. So make sure to hit that like and subscribe button for this channel, because every like and subscribe motivates us for making more such videos. Okay, if you have any doubts, you can write in the comment section, or you can join this Telegram group. It's dedicated for 2026 batch students. All the relevant links you will find in the description box. So now let's start this video.
Guys, the question here is, given an array of n integers, your task is to replace elements with its rank in the array. So you will be given an array of n integers, and each integer in that array should be replaced by its rank. Now you will say, what is the rank? For that, let's just understand the question first with the help of examples. Okay, so this is an input given, that is 20, 15, 26, 2, 98, 6. So these are the integers in the array. Now you have to replace each of these elements with their rank in the array. So how rank is decided? So one rank will be given to the smallest element in the array. Second rank will be given to the second smallest element in the array. So on, last rank will be given to the highest element in the array. So if you will see the array carefully, so you will see that this 2 has been given rank 1, and this 2 is the smallest element in the array. Okay, and the highest element, that is 98, it is given rank 6 in the array because it is the highest element. So this is how in increasing order ranks will be decided based on the element, based on the sorted positions of the element. So smallest being the smallest rank 1, and highest being the highest rank 6, and in between smallest to highest, each element eh, with respect to their position in the sorted array, the ranks will be distributed. Okay, so this is how first example looks like. Okay, now let's just see the second example. So here also the concept is same. The first rank will be given to the element that is smallest in the array. In this case 1. Highest element is 15, so the highest rank will be 5. Okay, but you will say that total elements in the array are 6, so highest rank should be 6 obviously. But no, see here, two elements are getting repeated, 8 and 8. So only one rank can be given to a particular element. So in this sorted order, first 8 will come on the third rank. So therefore second 8 will also be given the third rank only. And then the number greater than 8 will be given the fourth rank, not the fifth one. So therefore the rank here is 5, but the elements in the array are 6. So this is how it is going. If the elements are same, then only one rank will be given to both of those elements. Okay, so I hope now the question is clear to you. Now let's just quickly go towards the approach of this question.
Okay, so guys, before moving ahead in the video, I would like you to know that on our top mid page of Code Bashers, we have TCS NQT exam preparation material. So all the sections that will be asked in your TCS NQT exam, we have the previously asked actual questions in this particular material, whether it is verbal ability, numerical and advanced quantitative, reasoning and advanced reasoning, advanced coding questions. All the previously asked questions are covered here. If I will show you the sample of, let's suppose, the reasoning PDF, so you will see we have the proper question, proper option, and the correct answer for it. Similarly, in the numerical also we have the proper question, the proper options, and the correct answer for it. The best way to prepare for any exam is by solving the previously asked questions. So now you have time of at least, I would say, 3 to 4 weeks before your TCS NQT exam starts. So best time is to start preparing now only. Okay, and for the first 100 students, we have a flat 20% discount on this preparation material. The coupon code I will give you in the description box. Do check that out. Okay, and the link of this material also you will find in the pinned comment. So now let's continue with the video.
Okay, so guys, we will be using the hash map based approach. How will you doing it? So see what we'll do. We will first sort the array because I've told you the rank will be given basis on the basis of the sorting. Okay. So smallest element will be given the smallest rank starting from 1, and highest will be the highest rank. So first we will sort the input array. Okay, I don't know what is this happening. Just a second. Okay. Yeah. Now it is fine. Yeah. So first sort the array. Iterate over the sorted array. Key will be in the hash map. Key will be the value. Uh, key will be the value of the array and value will be the rank starting from 1. So let me explain this point. So this is our input array. Okay, this is our input array 1, 5, 8, 15, 8, 25, 9. So this is our input array. What we'll do, we'll first sort the array. Okay, sort the array in the ascending order. So what is how will the array look like? So array will look like 1, 5, 8, 8, 9, 15, 25. Now what we'll do, we will iterate over this sorted array. We will iterate over this sorted array, and at every position there will be a variable called rank. Okay, so rank will be starting from 1. This is a variable. Now at every element we will check whether that element is in the map hash map currently or not. If it is not in the hash map, we will add it in the hash map and we will give the key as this element and value as the rank. So let's just start it by iterating the array. So first we are on this first element, that is 1. So is 1 present in the hash map? So answer is no. So 1 is not present in the hash map. So what we'll do, we will add this 1 in the hash map, and what will be the value? As I've told you, value will be the rank. So rank will be initialized with 1. So smallest element will have rank 1. So here rank will be 1. Now once we have added this element, the processing of this element is done. What we'll do, we will update the rank to 2. So we will update the rank to 2 because rank plus plus, because next element will get rank 2. Now we will come into 5. We will check whether this 5 is in the array or not. Oh, is in the hash map or not? So no, it is not in the hash map. We will add this key value, key 5 as key, and value will be the rank. So rank currently is 2. Now after this rank will update it to 3. Okay, rank will be updated to 3. So 8 we will be coming. So 8 is not in the array. Oh, hash map, we will add 8, rank 3. Now we will update the rank to, we will update the rank to 4. Now we will again coming to 8, this 8, and this 8 we will check whether it is present in the hash map or not. So answer is no, it is not present in the hash map. So we will, oh sorry, the answer is yes, it is present in the hash map. So we'll leave this element as it is. We will move towards the next element, that is 9. We'll check whether 9 is in the hash map or not. So we have added this in the hash map, and value will be the rank. Again rank will be updated by 1, that is 5. Okay, so that is 5. Next is 15. 15 is also not in the hash map. So 15 rank with 5. Okay, this element is done. Rank is updated to 6. Okay, now next is 25. So 25 is also not in the hash map. So 25 we will add, and the value will be 6. That is rank variable. So this is how all the variables will now be present in the hash map with key as their original value, and the value in the hash map as their rank. Now what we'll do, once our hash map is filled, now what we will do after this iteration is over of after this, iterate over the original array and print rank of the current element from the hash map. Now what we have to do, we have sorted the array, but now once the hash map is filled, we will have to iterate the original array, so that for every element we can print the actual rank. Okay, not the sorted ranks but the actual rank. Okay, so once we are coming to 1, so we will check from the hash map that what is the value, because value will represent the rank of that element. So it will be 1, so we will print 1. Then is 5, we will coming to 5, rank will be 2, so we will print 2 here. Then we are coming to 8, rank is 3, we will print 3 here. Then we are coming to 15, 15 value is 5, rank is 5. So then again we are coming to 8, 8 value is 3 only. Then we are coming to 25, what is the rank of 25? It was 6. Then we are coming to 9, what was the rank of 9? It was 4. So this is our actual output, that is 1 2 3 5 3 6 4. So 1 2 3 5 3 6 4. So this is our actual element. Once the hash map is filled, we will have to iterate over the original array. Now how we will, like once you have sorted the array, how we will know that what is the original array? For that, let's just move towards the code. And if you are finding this video useful till now and you have understood the question, please hit the like and subscribe button, because more such videos will be posted in future. And if you have not watched previous videos, the link you can find in the description box for this entire playlist. So now to understand how we can keep the original array after sorting as well, let's just move towards the editor. Okay, so guys, I have already written the code. Okay, so first of all, what we'll do, we will take n as input, that is how many elements will be there in the array. Then we will be declaring an array of size n. Then we are declaring the second array also of size n. Why this is second array is required? For keeping the original array's value. We will look line by line. Okay, then we are declaring our map, hash map, unordered map. Okay, and again, to use this particular library, it is inbuilt. You will have to use this particular library in the top, that is hash include bit slash stdc plus plus dot h. So you will just simply, you can simply use this unordered map. Okay, then we are declaring a rank variable, int rank equivalent to 1. Now we are taking the input of the original array. So for we are iterating over from 0 to n, and we are taking the input for the original array C in ARR of I. Okay. Next thing is, in the next loop what we are doing, it is important. Now what we are doing, this is our ARR of I. ARR is our original array. We are maintaining a copy of the original array, that is our BRR. BRR. Okay. So BRR is the copy of the original array, because this ARR, that is our original array, will be sorted after it. So we have to keep the original values also. So therefore we have made a second array, that is BRR, and it is a copy of the original array. So after this loop is over, what we are doing, we are doing the sorting of the original array, as I have told you already. Why we are doing sorting? Because to uh, find the rank of each of the elements. Next, what we are doing, now we have to fill the hash map. For filling the hash map, I have told you we will again be iterating over the sorted array. That is our original array now, because it is sorted. First, we will check whether the current element is present in the hash map or not. If the current element is not present in the hash map, by this condition we will be checking. If the element is not present in the hash map, what we'll do, we will simply add that element as a key in the hash map, and value will be the rank. Okay. We will, again I'm telling you, we will add that element as the key in the hash map, and value will be rank. And after the processing of that element is over, we will do rank plus plus. Okay, rank plus one. This was the case when the array element was not present in the hash map. But if that array element is present in the hash map, then in that case, what we'll do, we will do nothing. We will simply move towards the next element. Okay. Now, after this loop is over, our hash map is also filled, and it contains the rank of each and every element. Next, what we are doing, now we will be iterating over the original array. That is originally array. That is the BRR, because it was the copy of it. It kept the positions of original array. We know that now the original array is BRR. Now we are iterating over the BRR. Okay, and we are simply printing out the rank of that current element. So if on the first position, let's suppose 1 was there, so MP of 1 it will print. Okay, then MP of 2 it will print, then MP of 15 it will print. Similarly, because this is the original array, and we are just printing the rank in the original positions from the hash map. So this was all this particular question. Okay, this was the all the code. Let's just quickly run this code in the editor. So our original array was 7 1 5 8 15 8 25 and 9. Let's just run it, and we will see the output. According to me, it should give the correct output. So you can see 1 2 3 5 3 6 4. It was our expected output. Let's just try on the another input also. uh, okay, this input. So 2015, control C. Let's just try on this input as well. Just a second. Yeah, let's just try on this input as well. Okay, how many elements are there? There are 6 elements, space separated by single spaces. Just a second. Okay. Yeah, let's just run it. Let's just, then we will compare the output of with our expected output. So it is 435162. 435162. It is 435162. So our expected output is equivalent to the current output. So this particular code will pass all the test cases that will be given to you. So guys, the question here is, given an n into n matrix and an integer x, find the position of x in the matrix if it is present. Otherwise, print element not found. Every row and column of the matrix is sorted in increasing order. The designating algorithm should have linear time complexity. So what we are given? We are given an n into n matrix, okay, n into n square matrix, and the in the square matrix, how it is designed, if you will notice that the row is also in the sorted order, as well as the different columns are also in the sorted order. So if you will take this example, so 10 20 30 40, this row is also in increasing order. And if you look at different columns, so let's just look at first column, 10 15 27 32. So this is also in increasing order. So what you have to do, you simply have to find a particular element inside this matrix. Let's just understand with a basic example. So this is a n into n matrix that is given to us, 4 by 4 matrix. The target value is x is equal to 29. So you have to find the position of 29 inside this particular matrix. Okay, so see, just the things that are given are the row and column are in the increasing order. So here you can see that is 29 present inside this matrix. So if you will look closely, so this is 29. So answer is yes, the 29 is present inside this matrix. And once you have found that position, you will have to print that position. Okay, that 29 is present at 2 comma 1 position. That is second row starting from 0 index and the first column starting from 0 index. But there might be a case where the target value, that is in this case x is equal to 100, this particular thing, this particular what you have value is not present inside this matrix. Okay, so inside in this you will have to print element not found. So these are two examples. So it is very simple, just that you have to find the given element inside the matrix. The first approach that you will be thinking in your mind, okay, what you will do, you will simply iterate over the matrix and you will check for each of the element if that element is equivalent to the target element or not. If it is, so it means it is present, and if it is not, then it is not present. But that approach will be done in the x big O of n square complexity. But the catch here is that we have to design a solution which will be running in the linear complexity. Okay, if you will like go to every element and check, okay, this element is equal to target or not, then it will be done in big O of n square complexity. But but the same thing we have to do in the linear complexity, and the things that we are given is that the row and column are in the sorted order. So let's just quickly move towards the approach part. We will see how the approach is working. Okay.
Okay, so guys, before moving ahead in the video, I would like you to know that on our top mid page of code bashers, we have TCS NQT exam preparation material. So all the sections that will be asked in your TCS NQT exam, we have the previously asked actual questions in this particular material, whether it is verbal ability, numerical and advanced quantitative, reasoning and advanced coding questions, all the previously asked questions are covered here. If I will show you the sample of, let's suppose, the reasoning PDF, so you will see we have the proper question, proper option and the correct answer for it. Similarly, in the numerical also we have the proper question, the proper options and the correct answer for it. The best way to prepare for any exam is by solving the previously asked questions. So now you have time of at least, I would say, 3 to 4 weeks before your TCS NQT exam starts. So best time is to start preparing now only. Okay, and for the first 100 students, we have a flat 20% discount on this preparation material. The coupon code I will give you in the description box. Do check that out. Okay, and the link of this material also you will find in the pinned comment. So now let's continue with the video.
Okay, so this is an input matrix. Yeah, the rows are also in the increasing order and the columns are also in the increasing order. And our target value is 29. We have to find the position of 29 in this matrix. If it is present, we will have to print the coordinates of that. If it is not present, we will simply have to print that elements not present. So we have to do this in the linear order, not in the n square method. It is very simple. Just iterate over the array and check for each element. That is n square approach. But we have to do in the linear approach. In that case, what we'll do? So what we'll do, we will take two pointers. One is the j, which will be pointing towards the column. Then is I, that will be pointing towards the row. So we will begin our j and I with the last element of the first row. Okay, last element of the first row, this element. That is j is equivalent to n minus 1, I is equivalent to 0. So we will point I and j to the last element of the first row. Okay, this thing is clear. Now what we'll do, we will check whether we know that these columns are, these rows are also in the increasing order, and if we'll talk about this column, this is also in the increasing order. This thing we know. Now we will check whether our current element, that is 40, is it equivalent to 29? No, it is not equivalent to 29. Then we will check two things. If the current element is either greater than target or is either less than target. So if, so 29, target is 29 and we are having current value as 40. So it means that the current value is greater than the target. So it means that the target is less than the current element. So and we know that this row is in the sorted order. So if this is the case, then what we'll do, we will move towards the lower sides. Okay, where we can find the possible lower answer, because current element is greater than target. So if target is present inside the matrix, then we will have to move towards the lower part of that matrix. Okay, where lower elements are present. So currently we are 40 and the target is less than 40. So what we'll do, we'll move towards the lower part. So what we'll do, we'll do j minus minus. We'll simply go here. Okay, we'll simply go here. Okay, that j minus minus we have done if the current element is greater than the target. Now what is the current element? So current element is 30 because I is pointing to 0 and j is pointing to n minus 2. So current element is 30. Again we will check whether our current element is greater than target or is it less than target. So current element is 30 So and target is 29. So it means that current element is greater than the target. So again we will move towards the lower part of the matrix where lower levels are present. And where the lower levels are present, it is present on the left of J, because from starting from j equal to 0 till j equal to n, it is an increasing order. So we will move towards the, earlier we were at 30, so we will move towards the lower positions or lower numbers. We will have to move j towards the left side. Okay. Now the current element is 20. Okay. Now we know that, okay, current element is 20 and target is 29. So it means that the target is now greater than the current element. And where are the greater elements present? Greater elements are present towards the lower side of the matrix, because the columns are also sorted in increasing order: 20, 25, 29, 33. So it means that, okay, current element is smaller than target, so we have to move towards the higher elements. To move towards the higher element, we will move I now. We will do I plus plus. We will move towards the next row, because we know that at downside of the matrix the greater elements are present. Okay. Now the current element is 25. Now we will check, okay, so is 25 less than 29 or it is greater than 29? So it is less than 29. So again we have to move towards the higher numbers. Higher numbers are present to the below of the matrix. So below of the matrix we will go. So it is now I plus plus we will do. Now the current element is 29, and yes, target is also 29. So we have found the element. We will simply print the position of I and j. So I is 2, j is 1, 2 comma 1 we will print. We have found the element. So I hope this thing is clear to you. Now, even if this thing is not clear to you, let's just now find out 100. That is the next test case. Again, what we'll do, we will start with this. I and j will start with the last element of the first row, 40. And we have to find 100. So 40 is less than 100. So what we'll do, to move towards the larger elements, we will move I towards the below. We will do I plus plus. Now 45, 100 is again greater than 45. So we will have to move towards the larger values. Larger values, for moving towards the larger value, we move I. We will do I plus plus. So we'll do I plus plus. Again, 48 current element. So 48 is again less than 100. So again we have to move towards the large element. We will move I plus plus. Okay. Then again 50 is also what you will say, it is less than 100. So again we will move towards the higher numbers, and we'll do I plus plus. So once we are done I plus plus, our matrix is over. So till even, so I has become great equivalent to n now. Okay. And j is still there. So if any of the elements, any of the variables, if I becomes equivalent to n, then we will break, or j becomes less than 0, because currently j equivalent to n minus 1. If this j goes and becomes less than 0, then also we will break. So either of the conditions, if either of the conditions are true, we will have to break. If I becomes equivalent to n or j becomes less than 0, we will have to break. In that case, we have not found the element. This approach is known as the staircase method of finding the element inside a sorted matrix. Okay, I hope this approach is clear to you. Now let us quickly move towards the coding part of this particular question. Okay, so guys, for saving time, I've already written the code. Let's just read line by line. Okay, so first of all, n is the number of rows and number of columns present, because it is a square matrix, so number of rows and columns are same. Then we are doing input of n. Then we are declaring a variable bool found is equal to false, because we have to check whether we have able to found the element or not. It will be used later. Then we have declared the 2D array. Then we have taken the target value, that the element that we need to find. So these loops are for taking the input for the array. Okay, I have written the code in C++. Then we are doing C in target, that is the element that we need to find. If we are able to find the element, then what we'll do, we'll simply print the coordinates or I or j position. And if you're not able to find the element, we'll print element not found. Then I told you that we will begin our search from the last element of the first row. So it will be j is equal to n minus 1 and I will be 0. Then we will be iterating over the array in the staircase manner. And I have told you what will the break condition if either of the conditions is is false. That is, we have to iterate while our j is greater than or equal to 0. Till that point we have to iterate, and if our I is less than n. So if within the boundaries we have to iterate. If any of these conditions becomes false, it means we have to break out of the loop. It means that the element is not found. Then once we are inside the loop, if the current element is equivalent to the target, we'll simply print out the coordinates. Okay, and we'll print found is equal to true, that we have found the element, and we will break from the loop. In the other case, if our current element is greater than the target, then we'll move toward the lower part of the matrix, lower part in the sense that where the small elements will be present. So that will be a column behind one. So we will do j minus minus in that case, if we have to move towards the smaller elements. Else is the case where our current element is less than target. In that case, we have to move towards the bigger elements. And for moving towards the bigger element, we will do I plus plus. That is toward moving towards the next row, because the elements are in the sorted order in rows as well as in the columns. So by this, we will be iterating over the array. And if our found variable is true, then we will not print anything. If our found variable after iterating over the array is still false as we have initialized it, then it means that element is not found, and we'll simply have to print not found. So this is the entire code that you have to write for staircase pattern. Let's just see with the help of an example. So we have taken a matrix of 3 into 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. These are the inputs. Input should be in the increasing order. And 10 is the element that we are trying to find. So in this case, element not found should be printed. So let's see. So yeah, not found is printed. If we will let's just suppose we have to find 9. So in this case, 2 comma 2 should be printed. That are the coordinates starting from 0 index. So 2 comma 2 should be printed. So yeah, 2 and 2 is printed. So this is how you will have to write the code in your exam. This will pass all the test cases that will be given to you.